So list is a sub-interface of collection. It contains index-based methods, like for inserting the elements in the index-based, getting the element from the collection based on the index, and deleting the element based on the index. So all index-based methods will be provided in the list interface. Normal collection interface contains normal methods. You can insert direct element. You can insert a collection of elements. You can delete element based on the element name. Right? All these element based are there in the collection interface. When it comes to list interface, you have a methods. Same methods are there, add method, but index based methods will be there. That means particular position you can insert, particular element based on the index you can delete. All index based methods you can get in this list interface. Basically, list contains duplicate elements. You can insert the duplicate elements in the list collection. List is ordered collection. Which order you inserted, same order will return to you. List interface is extending to collection interface, and list is implemented, list interface is implemented in the ArrayList class, linked list class, vector classes. 3 classes inside the list is implemented. See the structure of list interface: public interface, list. This is the angular bracket inside, whatever is there, that's a generic call. I'll cover that. Extends collection interface. Interface extends another interface. That's what the relationship I have given in the interface topic. So again, you can see the methods. Add int index element. You can insert this element in this position. This is coming because you already extended, right? Extend means what? All the collection methods will come to this field interface, right? This method is coming from collection interface. There is only one parameter. Add all method collection. So this is coming from the collection interface. See, add all method int index, comma, collection. See, the index based again. This method is declared in the list interface. So for add, you have 4 methods now. One is index based, you can insert the element, or a direct element you can insert, because this is coming from the collection interface and this is coming from the list interface. Add all is all similar. Clear method, you can clear the elements from the collection. You can delete all the elements from the collection. Equals method, you can compare collection element with given object. Hash code method, I already told you hash code method will fetch hash code of the particular object. So this is the one very important. Get method. How can you access particular collection element, list collection element? Get of int index. You give collection name dot get int index. So generally in the array, how we are accessing the array elements? Array name, square bracket, index number, right? But here you have to give collection name dot get method you have to call. In the bracket, you have to give the position. Which position element you want. So how to access list collection elements? Collection name dot get parenthesis int index you have to pass. So please remember, this is very important. We are going to use this several times, this one. Is empty. It checks whether the collection is empty or not. Last index, we can find out the last index of given object if it is repeating. So to array, you can convert the array into object. So collection into object, collection into object array. So any other type of, you can convert this. T means a type, different type also you can convert. This one is returning the object array. But this one you can convert it to any other type also. That's the meaning of this to array overloaded basically. Contains. So whether it will check whether this object is present in the collection or not. Contains all collection C. It checks whether this element, the collection of elements are present in the main collection or not. So you can find a particular element index, you can find out. Index of. Remove index. Remove int index means given position, what element is there, you can delete from the collection. So that's a remove method. So these are all methods very important. Set. You can set in this position this element. The set method also very useful. So these are the methods mostly we'll use. And list iterator, we have seen iterator interface. List iterator is another interface which is used to traverse elements in backward and forward direction. Whereas iterator interface is used to traverse the elements in forward direction only. But that iterator interface you can use for list collection and set collection for both. But this list iterator, you can iterate both forward direction and reverse direction also, backward direction also. But this you can use only for list collection, not for set collection. So here you have a has next method. Same way has previous methods also available in this list iterator interface. See, list iterator, a public interface, list iterator extends iterator interface. The parent of this interface is iterator interface. Just now we discussed. That's the list iterator interface. So all the methods I just mentioned, those are the methods. Now, ArrayList class. What is ArrayList class? Java ArrayList class uses a dynamic array to store the elements. How it will store array? A dynamic array. So you don't need to specify the size. So whichever the order you have given, same order, it will store one by one in the memory. So basically, the super class for the ArrayList class is abstract list class, and ArrayList implements the list interface. List is extended to collection, collection is extended to iterable. So this is the hierarchy of ArrayList class. So some of the points, let's understand the some of the points. ArrayList class can contain duplicate elements because list contains duplicate elements. ArrayList class maintains the insertion order. ArrayList class is non-synchronized. ArrayList class allows random access because it works based on the index. You can randomly access anywhere you want from the collection. That's the ArrayList class. ArrayList class manipulation is slow because a lot of shifting needs to occur if any element is removed from the ArrayList. So because, for example, you removed in the middle second position, what will happen? Third position element will go to second position, fourth way, like that shifting will take. So if one position element, if you remove, the other elements will move to that position, right? So that's the shifting will take place when you remove some element. So hierarchy of ArrayList is public class ArrayList, extends abstract list, implements list, random access, clonable, serializable. So these are the so how this ArrayList class, you see ArrayList class extends another class and implements list interface, random access, clonable, and serializable. Okay, so this is the hierarchy of ArrayList class. So the methods are these are constructors, ArrayList class constructors, default constructor. You can create a ArrayList collection by creating object for ArrayList class without mentioning any elements. So ArrayList class. So here itself you can mention all the collection of elements while creating the collection line itself. And you can specify the ArrayList size also here. Build an ArrayList that has the specified initial capacity. So this is the three constructors are available in the ArrayList class. Same methods, whatever the list methods, here also same methods. We don't need to discuss again, already we discussed. Second class in the list is linked list class. So what is linked list? So linked list basically another class which implements the list interface. Linked list follows the doubly linked list to store the elements. You can insert the elements from the beginning, from the back also. Both sides you can insert the elements. That is called linked list. So basically linked means one element will link to other element. That's a linked list. It's like a chain. That's a linked list means. Basically one element memory address pointing to other element. So that's the linked list, how it will chain. So it inherits the abstract list class and implements list and DQ interfaces. Linked list implements the list interface and also DQ interface. Both interfaces are implemented inside the linked list class. But ArrayList implementing only list interface. So linked list class can contain duplicate elements because list contains duplicate elements. So linked list class maintains the insertion order. Linked list class is non-synchronized. Linked list class manipulation is faster than ArrayList because no shifting needs to take place here in the linked list. So linked list class can be act as a list, stack, or queue. But ArrayList can act as a only list. So this is how you can insert these elements. You can insert and this memory address pointing to other element. So this is the you can insert here. You can insert here also. That's the W linked list means. A public class linked list extends abstract sequential list, implements list, comma DQ. Clonable, serializable. These are common. So these are the three interfaces. You can constructors, default constructor, parameterized constructor. So methods, there are a lot of methods are here. So you can just go through all these methods. There is extra methods you'll get here. Get first to, get last to, last index of. So many other methods. Peak method, what it will, it retrieves the first element of a list. Peak first, so it retrieves the first element of the list. Peak last, you can get the last element. Poll, it retrieves and removes the first element of the list. So poll first to pop, pops an element from the stack represented by a list. If you're using linked list as a stack, you can use these methods. Poll, pop, peak, these methods you can use. So then vector, so vector class. So vector uses a dynamic array to store the elements, same as a ArrayList, but ArrayList is a non-synchronized, but vector is a synchronized and contains many methods that are not part of the collection. So this is the legacy class. So vector class. That means very old class. When the Java starts collections, that time onwards this class is there. Stack means, stack is the subclass of a vector. Basically stack means, last in first out data structure. Like a go down is an example for the stack, right? So when you're keeping a last element, that you can take it out first. Queue means like you are standing in the cinema tickets queue, first in, first out order. That's a queue. So that's the difference between stack and queue. And queue is implemented by priority queue. DQ is implemented array DQ, right? So these are the stack and so queue differences. And stack has many methods like push to peek to, and so you can push the elements into stack. You can take it back with a peek method, pop method. All these methods you can use with a stack. So what is the difference between ArrayList and linked list? So this is one of the interview question. I face a lot of in this time. This in the years I faced this question: ArrayList and linked list. And ArrayList internally uses a dynamic array to store the elements. Linked list internally uses a doubly linked list to store the elements. So manipulation with ArrayList is slow because it internally uses an array. So if an element is removed from the ArrayList, so all the bits will shift. So that's why a little bit slow. So manipulation with the linked list is very fast because no shifting needed here. So that's the reason it is very fast manipulation. So ArrayList can act as a list because it implements only list. Linked list can act as a list or a queue, both because it implements the list and the DQ interfaces. ArrayList is better for storing and accessing the data. Linked list is better for manipulating the data. So that's all about list interface.